Assalamualaikum and hi. We are from Group 2. For this hydraulic laboratory, we choose Bernoulli equation for this group project experiment. This group includes 5 members, including me. So let me introduce myself first. I am Khairul Ehsan bin Zul Aziz, matrix number 20242500094. Let me start with introduction for this experiment. Bernoulli's principle is one of the key concepts in fluid mechanics, explaining the relationships between pressure, velocity, and elevation in flowing fluid. This principle helps us understand how fluids behave when they pass through different sections of a pipe or channel. In this experiment, we apply Bernoulli principle to observe how fluid pressure and velocity change within a pipe of varying diameter. The outcomes of this experiment are essential for real-world applications such as the design of pipelines, pumps, aircraft wings, and other flow systems. This slide showing 4 objectives of this experiment. First, to verify experimentally the validity of Bernoulli's theorem for fluid flow under steady condition. Second, observe how pressure varies along different sections of a pipe. Third, enhance understanding of the practical applications of Bernoulli's principle in fluid flow systems. Fourth, verify the validity of Bernoulli's principle through experimental data.
Hi, Assalamualaikum. My name is Sama KB Ramzi, and today I'm going to present to you guys the learning outcome and the basic concept of the Bernoulli experiment. The first learning outcome is to understand the concept of Bernoulli's principle and its application in fluid flow. The second one is to demonstrate how pressure and velocity vary along different sections of a pipe. The next one, relate theoretical knowledge to practical observation through experimental data. The fourth, identify real-world engineering application where Bernoulli's theorem is applied. And the last one, to develop skills in using fluid mechanics laboratory equipment and interpreting experimental results. The basic concept of the Bernoulli experiment is the Bernoulli theorem is a fundamental principle in fluid mechanics that describes the behavior of fluid flow in relation to pressure, velocity, and elevation. It is based on the law of conservation of energy, stating that the total mechanical energy of the flowing fluid remains constant along a streamline, provided there are no energy losses due to friction or other factors. According to Bernoulli's principle, when the velocity of a fluid increases, the pressure exerted by the fluid decreases, and vice versa. This relationship is commonly observed in applications such as pipe system, air valves, and venturimeters. The Bernoulli experiment uses a specially designed apparatus to demonstrate this concept, allowing students to observe the variation in pressure and velocity at different sections of a pipe with changing diameters. Thank you.
Assalamualaikum and very good morning. We are from Group 2, Class 2B1. So for today, hydraulic laboratory, we are given a task to do a video about experiment. So we choose Bernoulli apparatus for this video group project. Okay guys, so I'm going to show you guys the Bernoulli apparatus for this test. So the first one is here. This is inlet valve. This is venturimeter, outlet valve, and 6 foot pressure meter. And this is the probe to measure oil pressure. To begin the procedure, firstly, we must switch on the main switch first. Second, we need to close the inlet valve, and then we open the switch. Make sure Then we need to wait. When all the bubble disappear, we close the valve and then we open this valve. We need to water at 140. All this pipe must be same. Okay, we wait first. Okay, this level water almost same. Okay.
Okay, so next step, we record the time taken from 0 to 5 liter. Okay, so record the data. Open the valve. So after we get the 5 liter for the volume of tank, so this is data that we get from the monitor.
After we done this, we should repeat the same procedure for 2 times more to get 2 more data. Okay, that's all for us. Thank you very much.
Okay, now I will explain for the calculation, right? So the sample calculation I show for test 1, and the calculation for tube 1 is firstly we calculate the cross sectional area. So the formula for this tube is pi d square over 4. The diameter for tube 1 is 0.025 meter. So we calculate the area and we get 4.909 exponent negative 6 meter square. So this is the area for tube 1. Okay, next we calculate the flow rate. Okay, Q. The formula for flow rate is volume over time. So the volume we use is 0.005 meter cube and the time is 94 seconds. So we divide and we get the flow rate is 5.32 exponent negative 5 meter cube per second. So this is the value for flow rate. Next, the third is velocity. Okay, for the velocity formula is Q over A, flow rate over area. So we insert the value for flow rate 5.32 exponent negative 5 meter cube per second, and the value of area 4.909 exponent negative 6 meter square. So the value that we get for velocity is 0.108 meter per second. Okay, next is we calculate the velocity head. The velocity head formula is v square over 2g, right? So we insert the value of velocity that we get 0.108 square divide 2 times 9.81. So we get the value for velocity head is 5.94 exponent negative 4 meter. Alright, for the last calculation is find total head. So the total head in unit meter. Okay, so to find the total head is velocity head plus manometer level. So the manometer level, the data from the experiment. Alright, so the velocity head is 5.94 exponent negative 4 meter plus 0.14 meter. So we get the answer 0.141 meter for total head.
I am Ahmad Farhan bin Muhammad Osman. Right now, I will explain about discussion about this project. So, water level change varies both flow rate and pipe diameter in this In this lab, we use 5 different size of manometer and 3 types of flow rate. First one is 4.32 meter square per second. The manometer level generally increase pressure was applied, but pipes with diameter of 13.9 millimeter, 11.8 millimeter, and 10.7 millimeter show a decrease in level. What we can conclude, decrease of water level at 3 point this because of the velocity increase and static pressure drop because of Bernoulli effect. And the second flow rate, which is 5.43 meter square per second. All pipe in a manometer level show an increase in water level after pressure was applied. The system may be stable and the pressure is building up constantly. At the higher flow rate at 6.41 meter per second, 3 pipes in manometer level, which is 10.7, 30.9 and 35 millimeter, experience a drop in water level as velocity increase according to Bernoulli equation. Static pressure drops leading to many meter levels reduction. Overall, the result confirm the pipe diameter significantly influence pressure head and flow behavior in system. That's all from me. Thank you.
Hello, my name is Ahmad Hakim Muaz bin Samad. I will explain the conclusion for this experiment. The Bernoulli theorem experiment has successfully demonstrated the fundamental relationship between flow velocity and pressure within a pipe that has varying cross-sectional areas. Through the experiment, it was clearly observed that when the fluid passes through a narrow section of the pipe, its velocity increases while the pressure decreases. On the other hand, at the wider section of the pipe, the velocity of the fluid decreases and the pressure increases. These observations are consistent with the principle explained by Bernoulli theorem, providing that the theory is applicable to real fluid flow situation. In addition, this experiment has provided students with the opportunity to better understand the behavior of fluid flow, especially in situations involving changes in pipe diameter. Students also improve their skill in handling laboratory equipment such as the manometer and test pipe. Overall, this experiment has strengthened students' understanding of Bernoulli principle and its relevance to fluid mechanics. Thank you.